Let's have another example. So we are tasked to evaluate the Laplace transforms of the quantity 1 plus cosine t raised to the second power. So there is no principle that Laplace transform of the quantity 1 plus cosine t raised to the second power is the plus transform of 1 plus cosine of t, then i-raise natin sa second power. There's no such thing as that. So, ibig sabihin, i-expand na lang natin ito and then use linearity property. So, you have 1 plus product of the two. So, that's 2 cosine t plus square of cosine t is now equal to, using linearity property, so that's the Laplace transform of 1 plus 2 must be put outside, Laplace transform of cosine of t, then plus Laplace transform of cosine squared of t. So again, using this principle, it's impossible na kukunin natin ang Laplace transform ng cosine and then i-raise natin sa second power. That's not possible. So we are to use an identity para ma-solve natin ang Laplace transform ng cosine squared t. So since cosine squared t is equal to 1/2 times the quantity 1 plus cosine twice the angle, then we can replace cosine squared t as 1/2 quantity 1 plus cosine of 2t. Then we have Laplace transform of 1 plus 2 Laplace transform of cosine of t plus Laplace transform of 1/2 using linearity property naman dito. And then plus Laplace transform of 1/2 cosine of 2t. Then that gives us Laplace transform of 1 plus 2 Laplace transform of cosine of t plus 1/2 Laplace transform of 1, because 1/2 times 1, 1/2 must be put outside. Then we have 1/2 Laplace transform of cosine 2t. Then Laplace transform of 1 and Laplace transform of 1, merong 1/2, merong 1, so that gives us 3/2 times Laplace transform of 1 plus 2 Laplace transform of cosine of t, that's s over s squared, plus yung coefficient ng t here, which is 1 raised to the second power, that's 1, plus 1/2 s over s squared plus 2 squared. But the plus transform of 1 is 1 over s, so that gives us 3 over 2s, because 3 times 1 over s is 3 over 2s, plus 2s over s squared plus 1, plus s over 2 times the quantity s squared plus 4. So this must be the Laplace transform of this function. So that's Laplace transform of 1 plus cosine of t raised to the second power. So that therefore is our final answer. So let's proceed with the next example. So you have here cosine 3t sine 3t. So again, there's no principle that Laplace transform of product is Laplace transform or the product of their Laplace transform. There's no such thing as that. So Laplace transform of cosine 3t times Laplace transform of sine 2t is never equal to Laplace transform of cosine 3t sine 2t. So all we need to do is to use an identity. So yung cos cosine sin at saka sin cos cosine. So if I'm going to use Laplace transform of cosine 3t sine 2t, so kailangan natin siyang i-express into sine a plus b at saka sine a minus b. So we have to express that as sum and difference between the angles for sine. So since sine yan, so gagamit ako ng sin, cos, cos, sin. Sin, cos, cos, sin. So if I have A, B, A, and B, if that's plus, this must be plus. If this is minus, that must be minus then. So since required natin is product of cosine and sine. So, ang kailangan mawala ay sine A, cosine B. So, I need to subtract the two equations. Subtracting the two equations, this cancels out. So, this gives us sine A plus B minus sine A minus B. And that is equal to, so this minus preceded by minus becomes plus, or change the sign of the subtrahend and proceed to that of addition. Magkakaroon tayo ng 2 cosine A sine B. Then cosine A sine B is therefore equal to 1/2 quantity sine A plus B minus sine A minus B. But A is equal to 3t, so that's cosine 3t. Sine 2t is equal to 1 half. Sine 3t plus 2t is 5t. Minus sine 3t minus 2t is 1 times t is simply t. So therefore, what we are looking for is simply Laplace transforms of 1 half quantity sine 5t minus sine of t. So using linearity property, so that's 1 half quantity Laplace transform of sine 5t minus Laplace transform of sine of t. So evaluating Laplace transform of sine 5t, so ang gagamitin natin, Laplace transforms of sine bt is b over s squared plus b squared. So this gives us quantity, your b is 5 over s squared plus 5 squared minus Laplace transform, ang b rito ay 1 because the coefficient of t here is 1 over s squared plus 1 squared. So simplifying, that gives us 1 half quantity 5 over s squared plus 25 minus 1 over s squared plus 1. So pwede na to as our final answer. So if you wish to use the LCD, that's fine. So but this can be our final answer there. So evaluate t cosine of 80. So that is equal to s squared minus a squared all over s squared plus a squared raised to the second power. So what we will be using here is derivatives of transforms. So that is the plus transform of t to the n f of t is equal to negative 1 raised to n multiplied by the nth derivative of that f of s with respect to s. So meaning to say, I just need to take the Laplace transform of this whatever f of t here, and then whatever the exponent that must of t, that must be the exponent of negative 1, and then it tells how many times the Laplace transform of that function must be differentiated with respect to s. So in this case, if I have here Laplace transform of t to the 1 cosine of 80, so all I need to do is to raise negative 1 to the 1 because that n is 1, and then your f of t here is equal to cosine of 80. So that is first derivative with respect to s because ang n natin ay 1 multiplied by the Laplace transform of cosine of 80, or derivative with respect to s of the Laplace transform. It's not multiplied by. So that is negative 1 times the derivative with respect to s of the Laplace transform of cosine 80. But there's a principle na Laplace transform of cosine 80 is s over s squared plus a squared. So that gives us s here over s squared plus a squared. So taking its derivative with respect to s, we will use u over v. So that's negative quantity s squared plus a squared raised to the second power. Gagamit tayo ng derivative of u over v is v du minus u dv over v squared. So that's why meron tayong denominator raised to the second power. V, that's s squared plus a squared times the derivative of u, that's derivative of s with respect to s is 1, minus u, that's s, multiplied by the derivative of v. Derivative of s squared plus a squared is 2s. And derivative of a squared, of course, is 0. So simplifying this further, that gives us s squared plus a squared minus 2s squared all over s squared plus a squared squared. So this s squared minus 2s squared is negative quantity. A squared minus s squared over s squared plus a squared squared. Then distributing that negative since it is preceded by a negative. So therefore, Laplace transforms of t cosine 80 is given by s squared minus a squared over s squared plus a squared squared. So that proves the formula for Laplace transform of cos t multiplied by cosine of 80. So how about this one? So we have to evaluate t cubed e raised to minus 4t. So we can use derivatives of transforms, or pwede na natin gamitin yung Laplace transform of t to the n e raised to 80. So gagamit lang tayo ng um, first shift property. So ang aking f of t I mean is t to the n. So my f of s there is n factorial over s raised to n plus 1. Then f of s minus a is simply n factorial over s minus a raised to n plus 1. So what we will use is this particular formula. So ang n natin here is 3, ang a natin ay negative 4. So substituting to this formula, the plus transform of t cubed e to the minus 40 is equal to n factorial, so that's 3 factorial, over s minus negative 4 raised to n plus 1. So that gives us 3 factorial. That's 3 times 2 times 1 is 6 over s plus 4 to the fourth power. So that gives us the answer for the Laplace transform of t cubed e to the minus 40. But we can verify that answer using derivative of transforms. So again, so using derivative of transform, that is equal to negative 1 to the n. So that's 3. Then we are to solve for the third derivative because that exponent determines how many times the function or the Laplace transform of its multiplier be differentiated with respect to s. So we have to take the Laplace transform of e to the 40. If f of t is negative 40, then its Laplace transform is 1 over s plus 4 using the formula 1 over s minus negative 4. And that is 1 over s plus 4. That is negative 1 to the third is negative third derivative with respect to s of 1 over s plus 4. So ang kailangan natin ay third derivative. So let y be equal to 1 over s plus 4. So what we need is the third derivative of this function. So first derivative, so gagamit tayo ng derivative of k over v is negative k dv over v squared. So your k is 1, so negative 1. Derivative of v, so that's derivative of s plus 1, plus 4 I mean, over s plus 4 to the second power. So but derivative of s plus 4 is negative 1. That's negative 1 over s plus 4 raised to the second power. So that's your first derivative. Taking the second derivative, so constant here is negative 1. So negative of negative 1, derivative of v, so that's derivative of s plus 4 to the second over s plus 4 to the second squared. So using this particular formula. Negative of a negative is positive, so that's positive 1. Derivative of s plus 4 to the second power using general power formula. So derivative of u to the n is nu to the n minus 1 times its derivative. So that's 2. S plus 4 to the 2 minus 1 is 1 multiplied by the derivative of this function that is being raised to that constant exponent. So derivative of s plus 4 is 1 over s plus 4 to the fourth power because squared raised to the second power is 4. So canceling this out, that gives us 3. Then our second derivative is 2 over s plus 4 to the third power. But since we are looking for the third derivative, we need to take the derivative of this function. So your k is 2. So that's k over v ulit. So that's negative 2, negative k. So negative of 2 is negative 2 times the derivative of s plus 4 to the third over s plus 4 to the third squared. So that's negative 2 times 3 s plus 4 squared multiplied by the derivative of s is 1 over s plus 4 to the sixth power. So again, ginamitan natin ito ng general power formula that n is 3, u to the n minus 1, so that's s plus 4, 3 minus 1 is 2, multiplied by the derivative of s plus 4 is 1. So simplifying this, cancel ito, may matitira tayong 4. So therefore, y triple prime here is negative 6 over s plus 4 to the fourth power. Then again, since Laplace transform of t cubed e to the minus 4t is negative derivative of third derivative of that function with respect to s, 1 over s plus 4, but this derivative is that, so therefore, the Laplace transform of t cubed e to the minus 4t is simply negative of that negative is 6 over s plus 4 to the fourth power. So which gives us the same answer as that. So proving derivative of transform.